Ladies and gentlemen, good morning from my side. My name is Noshin Omar from company Vestel Battery Energy Engineering from Belgium, a partner of SoliTek. Please accept my apologies that I am not able to be with you in Vilnius on this beautiful day, but I am going to do all my best to give an interesting presentation regarding the following topic: stationary batteries from development to protection, with a very clear focus on stationary applications. First of all, before starting, if we look to this figure, which is representing the battery storage markets, we see worldwide that this market is expanding due to the number of reasons which are related to instability on the grid, electricity, which are getting prices which are getting very high, increase of renewables, etc. And of course, the having more autonomy from an industrial or even household perspective. So we see here a huge increase, and this increase is reflected everywhere in the world, from China to Europe and other continents. But if we look to the market much more further, we see there is some specific segmentation in the market where the global battery energy storage market is moving very fast. And particularly, we see the biggest move is still the utility markets, which is quite very obvious, followed by commercial and residential, which is not a small part at all. And then the others which are related to that. And due to the reasons that I mentioned before, due to increase of the renewable energies and having much more need for smart grid globally, and also due to the increase of the electrification which comes to that. Now, if we look to the market much further, then we see actually from the grid-connected energy storage segmentation that there is quite a lot of differentiation there. We can see when it comes to behind the meter or in front of the meter for commercial and non-commercial. So we see there still the biggest market in that regard is in front of the meter, followed by the behind the meter residential and behind the meter commercial and industrial applications. That's something which we have to take that into account, and that means also it needs a specific focus in terms of design of the solutions and in terms of solutions which are cost efficient, but also which are meeting the technical performances. Now, if we look to that large-scale storage applications, I think you are familiar with that. More and more we see large containers, 20, but mostly they are 40-feet containers, above 600, 700 volts, and such type of container where you can have 2 to 4 megawatt-hour installed battery energy capacity. And then it can be combined in series, or it can be parallelized to reach the requirement that is needed. So on the right side, you see another example from BYD, where actually they are expanding that for large projects and how the configuration is typically happening. But you can have it also for commercial applications, for storing much more renewables, like the left one, which is coming from Belgium, and for the right one, that is in a typical modular battery system in a rack system that we use it more for data centers and even for commercial applications as such, which is typically a perfect solution for SMEs to get it installed. Now, when it comes to home storage, we see actually quite a wide range of variation there. We see typically in the middle top the rack system still with a modular battery modules connected with inverters, of course. Below we see the Tesla, which are water cooled. On the left side we see another one, GSL Energy, which is much more wall-mounted solutions. And on the right side we see the Modularity, which I was tackling that from that perspective, modules which are stacked above each other to reach the specific capacity combined with the inverter which is associated to that. So here in this dedicated market, which comes to home storage and residential, the modularity is something very important, but also the design should be done in a such way which is very easy for manufacturing to keep the cost down, and also, of course, should be very safe in operation, but also in handling. And from that perspective, in that field of residential market, there are typically two approaches. Either you go to low voltage, and when we speak about low voltage, we speak typically about 48 volt or 51 volt, and everything which is below 60 volt, which is European regulated, and above 60 volt, typically we are speaking about 400 volt. That's in two examples that I took it from LG Chem. But you have also to take into account when you go from one level of voltage to another, that means also you are dealing with another type of battery cells, and your modularity approach is changing quite a lot. This battery technology is using pouch cells, as you can see here in the middle. That's an example how they typically stack that with pro and contrast, which I will come later to that. But typically, that is how the industry is dealing with that. Now, when we speak about battery storage for stationary application in general, you have to take into account there are a number of requirements that they have to be fulfilled. First of all, that are the performances, long lifetime, typically over 10 years, good rate capabilities, power, energy, etc. But they have also to be very safe. There have been already some accident in the past with NMC batteries in general, so safety, and particularly in household application, is very key, and so on. It should be cost efficient, of course, and there are different approaches to become cost efficient, and I'm going to tackle that afterwards. And they have to be reliable and robust for the environment where they have to be used, and compatible, of course, with different inverter technologies. So the optimal battery storage is a trade-off and combination of all these factors that should be combined in a proper way. Now, in order to do that, the battery cell technology is a very key technology in that regard. So on the left side, you see typically a prismatic cells, middle cylindrical cells, and on the right side, you see the pouch cells. And there, it comes actually to the modularity and the safety. If we look to the prismatic cell, we have here a venting system where if there will be any gases, that the gases can be released. We have a similar for the cylindrical cells, but unfortunately for the pouch cells, we don't have any venting system. If there will be any gases generated due to any mid failure of the cell or the BMS, whatever, what you are going to have inside your cell and a balloon effect. So the gases will be accelerated, and they will be kept, and they will destroy the internal structure of the battery cell. And that is actually where big problems started with the pouch cells, and that is a solution which we are trying to avoid as much possible in this industry. So the most preferred solutions either are cylindrical cells or prismatic cells, but cylindrical cells typically have a lower lifetime, 1,000 to 2,000 cycles, and prismatic cells, they have a longer lifetime, which can go up to 8,000 cycles. Now, when we speak about that, we speak about lithium-ion technology as such, and when we speak about lithium-ion technology, we speak actually combination of materials on the cathode and the anode side. So here I summarize for you all the characteristics of lithium-ion batteries that we have on the market. That is lithium cobalt, which we typically use in our cell phones. That's maybe not so important. That's what Tesla is using, NCA, nickel, cobalt, aluminum as a cathode. NMC, which is LG is using nickel, manganese, cobalt. You see there typically cobalt and nickel are popping up, and that are quite very expensive materials. LMO, lithium manganese oxide, where there is no cobalt, there is no nickel. And the most popular one is actually lithium iron phosphate. Lithium iron phosphate is widely used and it has a good trade-off between good life cycle performances, power energy, but also is quite very attractive in terms of cost. Here, lithium titanate, I think will not handle that for applications, utilities, which needs quite high power performances, and silicon graphite that is actually to replace the graphite in the anode as such. So the most technologies, the key technology that is now used for all station applications due to the reason that I mentioned is lithium iron phosphate, and that's also what we are working together with the colleagues of SoliTek. Now, some type of industry, also the modularity is very important. And modularity means a solution which can be easily be extended in terms of voltage or capacity and a modular approach without having too much modifications. And that's an example here. You see a rack system composed of modules, which can be 5, 10, or 15, or 20 kilowatt hour, and you connect them in series to reach higher voltage or capacity to reach higher, and to parallel them in parallel to reach higher capacity. And then you start actually dimensioning your battery system for different needs and different types of application, which can be air-cooled, but more and more, I should say, for large container batteries, we go even to liquid cooling, and particularly some areas in south of Europe and even the Middle East, the air cooling is not fulfilling the requirements anymore. And that means the design of such type of technology is very important. Design, not only for manufacturing, but design also from a cost point of view. This is an example where you see number of cells connected in series and where there is bus bars to connect them in series, and there are some housing around that and so on. So the design to do that is going to affect quite a lot the cost and also the performances of the battery in an appropriate way. But of course, when we speak about and the manufacturability, we speak about a battery module, you have also to understand there are also electrical components which are should be considered like fuses, contactors, which are making and the BMS battery system, which are typically a part of a such type of a battery module at the site. This is an example how modularity can be cost efficient. Here you have a stackable and a module which doesn't require any wiring, simply where you can stack that in parallel to a specific capacity. Of course, the voltage will be then fixed for that specific scenario, which is in this case 51 volt. But actually, from handling and from integration point of view, is from end user is quite is very easy. It's just installing and placing them on each other without having too much cutting of cables or mechanical intervention, and that is making the TCO quite very interesting and also safer. But of course, to achieve an higher safety, which is a main concern of this industry, there are numbers of another aspects that should be considered. The modularity is definitely one thing, but also more and more we are making the battery system much more compact, much more solid, much more safer by integration of materials. But also the production is key element in that regard. We see a lot of batteries which are still handmade, where the mechanical connection between the battery cells are made actually by screws, and that's not the way how to do that. So they're more advanced manufacturing technologies based on laser welding, ultrasonic welding is very key. But also the monitoring of the battery cells and the modules and the pack in real environment on daily basis is a very key aspect that can be done by monitoring the state functions like state of health, state of charge of such type of batteries properly through cloud connected solutions or real time to see how they're behaving, and if there will be any troubleshooting that you can take them away. And advanced thermal management, of course, is very important because we want to keep the battery in a proper way. So typically artificial intelligence solutions, as I mentioned, which are related to cloud is the future that has to be tackling that accordingly. Now, thermal management is very important. We know that most of the home storage or even industrial applications are still air-cooled, I would say, either passive or active. But in order to keep the best performance for lithium-ion batteries, either NMC, NCA, LFP, the temperature window should be in the range of 15 to 35 degrees. If we go above 35 degrees, we will be bringing the electrolyte inside the cell in an unstable situation where we can create actually gases. And that's what I have been demonstrated by the pouch cell. So, and the lifetime will go down. And if you go often below 0 degrees, you will be destroying your battery due to lithium plating. Or if you go close to 0 degrees, your performances will go down. So it's very important to keep that. So the way where the battery will be installed and the conditions of that are very key, and it's going to decide a lot about the warranty which are related to that. And that's an example that I want to give, which gives actually the impact of the temperature over the lifetime of the battery. If you keep it in the window where the battery has been developed for, in that regard, you get the best performance. That's an example for cylindrical cells. But if you go down to very extreme low temperatures without heating, whatever, then you will destroy your battery very fast. And the same actually when it will be often at higher temperatures. So ideally, you have to stay here. If you have an operating window which is changing very fast, then heating definitely here will be needed, and cooling will be definitely there needed. So it's dependent on scenario and the conditions where you are operating. But having a good lifetime, good safety, good stability, we need also to bring the cells, the battery cells, in equal conditions in general. So that is actually the desired solution that we want to have. All battery cells are equal, and they can give the best performances. But if you will have scenario where there is huge imbalance between the cells and the battery memory is not able to handle that, then actually we are asking for problems. And that is typically where it's happening. And I can say many problems that occurred so far, explosions with home storage batteries, that were actually relating to the cell balancing failures, or the cell balancing current was not sufficient enough. In that regard, BMS is very important. BMS, which is cost efficient, BMS, which is modular, scalable. Scalable in series, scalable also in parallel is very important. And that is what we call typically a master-slave combinations, which can be easily adapted to different scenarios, or for low voltage, or for high voltage, or for parallelized solutions. So take into account the heart of the system as for us human beings, the heart of battery system is a BMS, and BMS has to monitor that from the thermal point of view, from the energy point of view, from safety, state function, everything. It's regulating everything in a proper way. And that means there are some requirements. That means that BMS should be possible to be used for 80-volt systems, low voltage, but also should be able to be expandable to 800 volt for large-scale applications in a modular way, where the design should be done in the beginning with the possibilities to be connected in series, in parallel, with monitoring solutions through clouds, as I mentioned before. So that is actually the duty of BMS, that is to be done in a proper way. And that means by doing that, you will be able to estimate the conditions, the operating condition of the battery much more accurately, precisely, to avoid any specific problem that potentially could happen. And that's a high accuracy is really needed. And that can be done also by data-driven models that can be integrated in such type of BMS to predict, estimate, and also to monitor the battery behavior in a proper way, which can be sent through a cloud to host office to check the details and the behaviors in order to avoid any problems or troubleshootings. Nevertheless, design should be done properly. That is also matching the production processes in a cost-efficient way. So the cost efficiency is typically defined by a proper design, and the proper design should be matching the production process to do that in a cost-efficient way. I have seen different product designs which were very good, but from manufacturability, they were quite very difficult to do. So take that into account, the manufacturability and the design go hand in hand. And of course, as I mentioned, advanced manufacturing solutions should be integrated, like laser welding or ultrasonic welding, or even inspections, how the welding happened, etc. That all should be done in a proper way. Otherwise, problems and the quality will come above. Safety should be monitored. Why? Because we are dealing with lithium-ion technology. Lithium-ion technology, they have good characteristics, but they have also some bad characteristics. Let to be very clear. If we stay in the window of, let's say, up to 40, 50 degrees maximum, then everything is fine. But if we go above 70, 80 degrees, that is typically where problems are. And the problems start typically around 100 degrees, when there will be some failure mechanisms, that your mechanisms and system inside the battery cell will start creating problems. Electrolyte will not be stable. The binders will not become stable anymore. And then you will get a shut-off of different mechanisms over the time, and you will see the temperature will just increase. And then this temperature will increase in chain reaction mechanism. And when it will reach 1,000, 1,100 degrees, then you get typically an explosion, and a very aggressive explosion, where a lot of gases also will be coming out. So please take into account where you install the batteries, either in residential or in commercial or even industrial. Be careful that should be also good ventilation and good sensoring for measuring some number of gases, which I highlighted them for you in red. But nevertheless, in Europe, we are going to have a new rule, which we call it battery passport. And this battery passport is going to monitor all the details from where the battery has been produced, based on which type of energy, was it green or not, which location, which type of materials has been used, and to the ends. Here I just took an example of the process, how it's going to happen, and where it's going to be mandatory from European Commission starting from 2025, 2026 to get that. Why? Because in Europe, we don't want that battery will be imported, which have been produced in non-green way, in order to secure our market. So take that into account. There will be a lot of restrictions of imported batteries to support the local industry, which are going in the sustainability and which have also social responsibility. For that, Europe has identified a number of targets. So please take into account, in Europe, there is also a rule which says, if you produce batteries above 20 kilograms, then you are automatically also responsible for recycling. So that is, this responsibility is very key, and those recycling efficiencies are going to be enhanced over the time. Now we are at 55%. 55% of the input material should be recycled. By 2025, we are moving to 65%, and by 2030 to 70%, which means that in the past, where only nickel and cobalt were recycled, is not going to be enough. We have now to recycle lithium, copper, aluminum, and other materials as well, because such materials should be used again as an input material for new battery types. There is another aspect that should be considered when recycling should be done. Recycling should be done also in human way and responsible way. And on the left side, you see typically where in some area, I don't say everywhere, where some area recycling is happening. That's not the way where we want to have it. That's not the human way, not the healthy way, not respectful way. And also recycling, doing that close to houses, close to schools, close to play gardens, that's also not responsible. I just took this example from cattle in China, where big disasters happened when there was an explosion in one of their recycling plants. It was an environmental disaster to tackle that. So please take into account a design or implementation of battery just more than just implementing that is in a full aspect which is behind that should be respected as such. So as a conclusion, strategies toward cost efficiency, modularity of battery design is very important in the cell selection, because the cell selection is going to define the modularity constraints. Modularity battery systems based on 48 or 51 volt is right now for home storage residential are making the best chance for safety reasons and cost reasons. BMS is going to be a key aspect, in that regard, in terms to enhance the safety lifetime, but also to have these modularity functionalities. And we see a trend. In the past, we had much more battery modules of 2.5 kilowatt hour. More and more, we go to 5 and 10 kilowatt hour for the reason, because for every module, if we will be using a BMS, that is going to increase the cost quite a lot. And of course, last but not least, for a battery, you need also an inverter, and this inverter should be compatible with the BMS. So it's different approaches that should be tackled in that regards, and which are going to decide in which way it can be produced cost efficient or not. I want to thank you for your attention, and again, please accept my apologies that I couldn't be with you. And if there will be any questions, I will be glad answering to them. Thank you very much.